Alright, hello friends, hope you're having a fantastic day. Today we are going to deal with your two favorite things, fractions and factoring. Alright, so look at this. So let's go back and see what we remember. Now remember, when adding or subtracting fractions, you must have a common denominator. Once you have a common denominator in place, we just add or subtract the numerator. So 2 minus 7 in this case would give me negative 5 over 3. That's it. In the event you would have to reduce, you could do so. And remember, it's different than multiplication, because in multiplication we go straight across. Here you must have a common denominator. It stays the same. Here now, in the event you don't, you have to find a least common denominator. In this case, what's a multiple that 5 and 3 share? We would have 15. So the 5 is missing a 3, and the 3 is missing a 5. So you got to multiply top and bottom by 3, so you get negative 12 over 15 plus 35 over 15. Alright, so to get to 15 we have 5 times 3. Now we add the tops. Negative 12 plus 35 is 23 over 15. Can it be reduced further? Nope. So we leave it as is. Now, the same idea applies even if we're dealing with variables in the denominator. So we have the same denominator. If we didn't, we would have to make sure it was. So 3 minus 7 gives me negative 4 over 2x. Now, in this case, you can simplify. Negative 4 divided by 2 gives me negative 2, and the x just stays on the bottom. So you can simplify the numbers with the numbers. All right, not so bad. So now we're going to apply the same principle to adding and subtracting rational expressions with unlike denominators. Alright, so now the first thing you always have to determine is an LCD. Now the way you do that is you factor the denominators. So let's just focus on the denominators. Here there's really nothing to factor because it's one term. Here we have a GCF of 3x squared. So inside the parentheses, I'm left with 2x minus 1. All right, so now looking at these two things, all right, we need to find something, combine them both, and then add what's missing. So what do I mean by that? Well, this has a 3x squared, and this has a 3x squared, right, and one more x. All right, and then this has a 3x squared and a 2x minus 1. So over here on the left, we're missing a 2x minus 1. Over here on the right, we're really just missing an x. So my least common denominator is going to be 3x to the third and 2x minus 1. So in a sense, you're combining everything in both. All right, so looking over here on the left one, we have the 3x cubed. We're missing the 2x minus 1 part. I'm sorry, that's plus 1. Why didn't you guys say something? You can't talk to me in the video. Okay, so 2x plus 1. My mistake. Please make sure it's correct on your notes. So over here we're missing a 2x plus 1. Alright, and over here we're missing an x. Alright, because we have the 3x squared and the 2x minus 1, our denominator is just missing an x. So now you're going to multiply the top with that. So 4 times 2x plus 1, the piece we're missing, and we're going to add it to x, the numerator, times the piece we're missing. Now your denominator is always going to be your LCD, your least common denominator. That's why it's very important to figure that out first. Alright, good. So now, once you have this, you have to multiply out the top, the numerator. So I got 8x plus 1, sorry, 8x plus 4, you distribute the 4 to both. 8x plus 4 plus x squared all over 3x cubed times the quantity 2x plus 1. And now I'm going to rewrite the top just so it looks a little more familiar to you. I didn't change anything. Alright. Sorry, 3x to the third times 2x plus 1. Alright, now you look at the top to see if it can be factored. Do we have two numbers that can multiply to 4 and add to 8? Well, no, that's impossible, so sometimes that happens, and that's my answer. Now, on a number of occasions, you'll be able to factor this. For instance, let's say you got something like x plus 2 times 2x plus 1 and then the bottom would look like this. In that case, these terms would cancel, okay, and this would be your solution. Again, a lot of times that happens. In this case, it didn't, so you have to be able to adjust either way. Okay, you got to look at it. Say, can it be factored? If it can't, you're good. If it can, you factor further, and you may cancel stuff out, similar to what we did yesterday. So not that bad. The only new piece, find the LCD, keep the denominator in factored form, and then keep simplifying until you can't anymore. That's really all it is. Let's try another one. So again, start with the denominators. Can that be factored? Well, two numbers that multiply to 9 and add to 6 give me x plus 3, x plus 3. Then over here you have a difference of two squares. So x plus 3, x minus 3. Sorry, I'll make that a little neater. Alright. So now, let's determine my least common denominator. This one has two x plus 3s, this one has 1. So we need x plus 3, but we have two of them, so I'm going to square it, and x minus 3. So here on the left, we have the two x plus 3s, we're missing the x minus 3. Here on the right, we have the 1 plus 3 and 1 minus 3, however, we're missing the second x plus 3. Alright, so on top, I have x. Alright, so on the top, you're going to have to FOIL that out. So we have x minus 3 times x plus 1. We're subtracting 1 times x plus 3. And then that's all over your least common denominator. Now, I'm going to write it like this just for explanation purposes. But if you wrote it as squared, that's fine. Alright, so we multiply that out. We get x squared plus 1x minus 3x gives me plus 1x minus 3x minus 3. Over here you have to distribute your negative 1, so you get minus x minus 3. Your denominator stays the same. Right, combine all your like terms. I have x squared, 1x minus 3x minus 1x gives me minus 3x. Negative 3 and negative 3 give me minus 6 all over x plus 3, x plus 3, x minus 3. Alright, again, take a look at your numerator. Can you be factored? Two numbers that multiply negative 6 and add to negative 3. Well, that won't happen with 2 or 3 or 6 and 1, so that is your solution. I would simplify it a little to say this. Again, if you can factor the top and things can cancel, do so. In this case, it didn't happen again. Be able to adjust either way. So find the least common denominator, multiply by what's missing. Right, keep the denominator in factored form all the way through to see if you can cancel anything at the end. Factor till you can no more. Alright, now we're going to move on to complex fractions. Now complex fractions are basically a fraction that contains a fraction. Okay, so it's a fraction inside a fraction. Ooh, it's like Inception. Alright, so let's look at one. Pretty much, look at this. It's a fraction over two more fractions, the sum of fractions. So that's a complex fraction. Now, this gets a little different. Alright. Now, we're going to do the same thing. Alright, we're going to simplify the top. Alright, remember, dividing, we're going to simplify the bottom. And then remember, dividing by a number is the same as multiplying by the reciprocal. So once they're all simplified, we're going to create one fraction and condense it in a sense. Alright, so the first piece is simplify the top. Alright, simplify top, or the numerator. In this case, we have 3 over x minus 4. There's nothing to be simplified there. It's all by itself. Alright, our second step is to simplify the bottom. Simplify the denominator. Now, in this case, there is something to be simplified. So we have 1 over x minus 4 plus 3 over x plus 1. So the common denominator, it's like what we did on the front. This piece, my LCD, is x minus 4, x plus 1. So this is missing an x plus 1. This is missing an x minus 4. So when you multiply out the top, you get 1x plus 1 plus 3x minus 12. So I multiplied the 1 to both, and I multiplied the 3 to both, and my denominator stays in factored form. So then I'm going to simplify. Well, I get 4x minus 11 all over x plus minus 4x plus 1. Alright, so now I've simplified the bottom. Now my third and final step, alright, is to take the top in simplified form, and we're going to multiply it by the reciprocal of the denominator. Alright, so my top was 3 over x minus 4, that's my numerator, and now I'm going to multiply it by the simplified reciprocal of the basement, alright, of the denominator. So I'm going to flip this fraction, so I get x minus 4 over x plus 1, all over 4x minus 11. Okay, so I kept the numerator the same. That's where that came from. I changed division to multiplication. All right, and then I took the reciprocal of my simplified denominator. Now multiply straight across. 3 times x minus 4, x plus 1, all over x minus 4 times 4x minus 11. All right, now I keep it in factored form because watch what happens. We have an x minus 4 on the top and the bottom. All right, so I'm left with 3 times x plus 1 all over 4x minus 11. And that's that. All right, now I only have 3 minutes left on the video, so I'm going to fly through number 4, and then I want you to do number 5 on your own. So if you want to pause it and try 4 on your own, and then check your work, that'd be your best bet here. But I'm going to work through it really fast to make sure I have enough time to get it in. All right, so pause if you want to work. Go. If not, follow with me. All right, step 1, simplify the top. It's good to go. Step 2, simplify the bottom. Well, I have 1 over x plus 4 over x minus 1. So my LCD is x times x minus 1. This side's missing an x minus 1. This side's missing an x. So my numerator looks like x minus 1 plus 4x all over x times x minus 1. So I get 5x minus 1 over x times the quantity x minus 1. Alright, so I take in step 3, I take my numerator. I'm going to multiply it by the reciprocal of this. So x over x minus 1 over 5x minus 1. Notice you have an x minus 1 on top and bottom. So you get 2x over 5x minus 1. And that's that. Alright, and you can't combine the 2 and the 5 because you can't divide like that. We'll get more into these as they get more difficult. Okay, so again, try 5 on your own. Alright, you have to simplify the top and the bottom and then multiply them in the third step. Alright, good luck. I'll check your notes tomorrow in class. See you then.